All right. Well, hello everybody. My name is Nick Van Acker. I am an educator here at Michigan State University Museum, and I'm really excited to be welcoming you to the Science on a Sphere program, Animals on the Move. You'll notice it's not just me here. We're also joined by Alina Bowman, who is my co-presenter. She's one of our student presenters on this, for the Sphere. Alina, if you want to wave and say hi.
Hello.
Yeah, and so if you haven't attended one of our programs before, Alina is going to be helping kind of on the back end. So in Zoom, there is a chat function and a Q&A function. So if you guys have any questions, you can feel free to leave those there. Alina will be looking those over and reading those to me, just so we make sure that I'm not missing anything while I'm in the gallery, holding things up and moving the sphere around. And then we'll also be asking you questions throughout the program. So I might ask you just some general fact about animals. You can leave those answers in the chat, and Alina will also be checking those, reading those back to me, so we can have kind of a back and forth. But with that, we can get to the program today. So today we're going to be talking about animals on the move. I know I woke up the last couple of mornings and found it to be very, very cold outside, which means that the seasons are changing. And with those changing seasons come animals moving all over the place. So we have a couple of really cool data sets on the sphere that show how animals move based on the seasons and based off of a lot of other things. So I'm going to pull up our first data set right here. And this is one of my favorite data sets. Make sure that you guys can see it. I'll rotate it around so we can get there. And so what you guys are seeing on the sphere behind me are a bunch of black dots that are kind of floating around the sphere back and forth between North America and South America. But these are more than just dots. Each of these black dots actually represents a species of bird. So there's over 120 different dots on the sphere, and each of those is the center of a species. And as you'll see, they're flying back and forth. So an easy question for you guys, hopefully to get you started. What do you think the birds are doing here? Do you think that this is showing the difference between seasons? So what do you see the birds doing? It's something that we all know birds do. You can leave the answer to that in the chat. All right, we've got one answer here. Got one more answer. We'll wait for just a couple before I give the right answer, but you guys are right on the money so far. It's an easy one, like I said, to get us started. Yes, everybody's correct that's been answering so far. The birds are migrating, right? We all know about this. Birds fly south for the winter. They fly back up north when it gets warm. And this data set shows that in a really cool way. So you'll see there's two different colors here. Up on top of the sphere is blue, that represents cold temperatures coming down from the north. And on the bottom, the sphere is reddish yellow, showing the warm temperatures in the south. And so you'll see as the temperatures get colder up north, all the birds fly south for the winter. As the temperatures start to get colder in the south, all of the birds start to fly north. Now, something kind of interesting about bird migration that people didn't know for a while is that some birds don't actually migrate. So there might be birds that live in Michigan and they'll stay in Michigan for a long time, or there's sometimes birds will fly south relative to other birds. And what I mean by that is that there are birds that might be all the way up in the north of Canada, and for them, south is a place like Tennessee, for instance, whereas the birds that are living in Tennessee would have flown a lot further south to get warm. So birds constantly move based off of temperature. That's something we all know just to kind of get us started talking about migration. But something you might not know is that a lot of other animals actually move based off of temperature too. So we've got animals in the ocean right here, and it's going to be a little bit hard to see. Usually I like to ask people what animal they think this is, but it probably just looks a little bit like blobs for you. So I'll hold up an example of what this animal is, kind of put it in front of the sphere. You guys will leave in the chat what animal this is. It's an animal you probably all know as well. It's a turtle, yeah, everybody's correct. This is a sea turtle. And so you might not know that sea turtles actually migrate based off of temperature as well. So the turtles in this animation, they're showing the migration of turtles that were measured between 1997 and 2006. And as you'll see, they're swimming back and forth between Asia and North America. But what's really interesting is not only are they going east and west, but they're also migrating north and south. So right now you can see there's a big blue swash kind of across the top of this turtle migration, and that's representing cold water, the same way it was representing cold air with the birds. So the turtles obviously want to stay warm, so they'll swim kind of away from that cold water. This also reflects how currents move around the ocean too. So the turtles are using that current to migrate, so they use the temperature to kind of help push them along. So that's kind of another cool fact that people might not know. Turtles migrate as well. The way that this turtle migration is measured is actually using something that's called radio trackers. So it's basically like a big backpack that they glue to the back of the turtle. So that's one way that we can measure how animals move. I've got one more data set right here, and this is showing another cool animal that you guys might not know migrates. It's a bright data set, so wait, we'll move it around a little bit. While we're getting there, it's a little sneak peek on the sphere for you of what animal it is, but I actually have a real one of these animals. So if you guys can see that, if again you want to leave in the chat, what animal is this? Yes, Amy's got the idea. She sent it before I even asked the question. That's exactly right. Yeah, so this is showing a monarch butterfly. So you might not know, thinking about an animal that is so small, like an insect, it's easy to imagine these big animals like turtles and birds migrating around the earth. But monarchs actually have a really cool migration too. So we're looking at this data here on the sphere that comes from a place called iNaturalist. And iNaturalist is an app where anybody who wants to is able to sign up and then take pictures and make observations of animals that they see in their own backyard. They upload that information to the app, which creates a database online, and then scientists are able to look at that and see where animals are using data collected by regular everyday people. So this data is all from iNaturalist, and it shows how monarchs are moving across the United States. So I have a question for you that you guys can leave in the chat here. And the question is, like I said, it's easy to remember, to figure out a bird or a turtle flying these huge distances. But how far do you think an individual monarch is able to fly? And so I'm gonna give you guys some options. Do you think that a monarch can fly 3 miles? Do you think a monarch can fly 30 miles? Do you think a monarch can fly 300 miles? Or do you think a monarch can fly 3,000 miles? And I can wait just a couple of minutes to see that answer in the chat. Let's see. I can't stump anybody. Everybody's getting all the right answers. Yeah, so everybody is saying so far, oh, we've got a couple of them. Okay, I won't give it away then. We're seeing a couple answers come in. Okay, so a couple people said 300, but for the most part, everybody said 3,000. And that's the correct answer. So monarchs are actually able to fly over 3,000 miles as part of their migration. But that's not all monarchs, that's only a very special type of monarch. So the way that a monarch migration works is we can start off, say, in Michigan. So a monarch might live up in Michigan, and it hatches at the end of the summer as what's called a super generation. So all the monarchs born at that period are just really, really robust and really strong, and they're able to make the migration all the way from Canada or Michigan, all the way down to California or Mexico. They hang out there for the winter, they stay all nice and warm, and then eventually they lay eggs. Then those eggs hatch into a new generation of monarchs. But those monarchs aren't quite as strong, right? So they end up flying north just a little bit. Then those monarchs lay eggs, those eggs hatch, and then the new generation flies a little bit further north. So the one super generation is able to make this huge migration, flying all the way south, and it takes 3 or 4 generations to get back to the native land where the first monarch came from. This is really crazy. This is something that you don't see in a lot of other species. So it's a really, really cool migration story. Of course, it's unfortunate for the monarchs because by the time that last generation gets back to where the first monarch started, it's basically time for them to lay eggs and have the monarchs fly south again. So nobody gets to hang out anywhere for long. But it's a really cool, interesting story. And so we know, like I was talking about, we know why animals will migrate these different distances. Usually it's to stay warm in the winter. But that isn't the case for all animals. There's some animals that scientists are still trying to figure out why exactly they migrate and where they're migrating, honestly. So this data set behind me shows a lot of crazy green lines. There's a lot of red lines moving all around. And this data set is looking at 2 different animals. One of these animals is elephant seals, and the other is a type of bird called a sooty shearwater. Say that 5 times fast, sooty shearwater. You will not be able to, and I won't try because I might say something that I don't want to. But so the elephant seal and the sooty shearwater both migrate these huge distances. So elephant seals, as you can see, are going all over the ocean. But not only do they just hang out on the surface, elephant seals are actually moving up and down in the water column as well. They're actually able to dive up to 4,600 feet into the ocean, which is incredibly deep. And sooty shearwaters, even though it doesn't look like they're flying quite that much based off this data set, are actually able to fly, I need to look it up here, 46,000 miles per year. I always forget that number. I think it's going to be too big when I say it out loud, but that's the right number. It's 46,000 miles in a year. So scientists, of course, are really curious about how these animals are migrating that distance and why they would migrate that distance. So just like the sea turtles, they attached a sort of backpack to the elephant seals, but that didn't just measure temperature and location, that measured all sorts of things that might be useful in figuring out how elephant seals move. So it measured, for instance, ocean salinity, it measured pressure, it measured temperature, and a bunch of other stuff. And scientists are able to analyze that data and try and look for patterns to see if they can figure out why elephant seals migrate the places that they do. Birds are a little bit different. The sooty shearwaters did not have backpacks on them necessarily, because you can imagine a bird trying to carry a backpack around wouldn't be able to fly very well. So when we try and track bird migrations, we actually have a little bit of a different tool, and those are called bird bands. And so I have some examples of bird bands right here. This is from an exhibit we used to have at the museum, all about birds. But you can see that the bird bands are all sorts of different sizes. We've got a super tiny one right there, down at the bottom, you might be able to see. That's for a super tiny bird, you could probably guess. And they get bigger and bigger, all the way up to a gigantic bird band here. And this is for something like a sandhill crane. That would be a gigantic bird that a tiny little band wouldn't fit on. And these bands are super cool. These individual bands don't have any information on them. They, you might be able to see they have some numbers on them, but it's all just 0, 0, 0, 0. But actual bird bands have all sorts of information listed on them. So there's usually a whole bunch of numbers. It might say the project of whoever caught the bird and put the band on the bird. And there's just all sorts of cool things on there. And the idea of these bird bands is that when somebody catches a bird, and a scientist catches a bird, puts the band on their leg, they let the bird loose, and then the bird flies wherever it's going to fly. Another scientist might catch that bird as part of another study and be able to look at that band and then call the first scientist and say, hey, we found your bird all the way over here. And so that adds to all sorts of information about where birds are flying and how we're able to track them. Monarchs, I forgot to mention the method which we track monarchs. Some insects are tracked using little tags that are actually attached to their wings. It happens occasionally, but most of them are tracked like we were looking at on the sphere with iNaturalist data or just observations. And sometimes if a migration of insects is big enough, you can actually see it using weather satellites, which is really crazy. So scientists use all sorts of tools to try and track the animals that migrate across the entire Earth. But there's some animals that don't migrate across the entire Earth, right? So these animals have a range that they stay in. And honestly, the ranges of these animals are sometimes so small, we're not actually able to see it on the sphere. We partnered with Potter Park Zoo for this project, and we are looking at some of the animals that are available or not available, but some of the animals that live at Potter Park. And all of the ranges of these animals were so small, we weren't actually able to put them up on the sphere. So we'll look at pictures of them instead. So for instance, these are lions from Potter Park Zoo. You'll see that there's the 2 females and the male there. If you've been to Potter Park Zoo before, I'm sure that you've seen these lions. And lions will move around their habitat, but they don't migrate huge distances, right? So that brings up a question that I bet you guys can answer. You can leave the answers in the chat. Why would an animal move around its environment if it isn't migrating somewhere? If it isn't based off of, cold temperatures coming in that they aren't able to survive, why else would an animal want to move around its environment? All right, we've got one answer coming in. That's perfect. Yes. Oh, they're all the same answer. Everybody's got food on the brain. It's getting close to lunchtime. Yeah, so that's the first answer that everybody has put in. They said to find food, which is exactly right. That's the same reason that I move around every day. I wouldn't get out of bed if I didn't need to eat breakfast. So finding food is definitely a reason that animals are going to be moving around their environments. Yes, and we got another good answer there that says mate. So animals might be looking for a mate to try and reproduce, to have little baby animals. For lions, this is definitely the case. The males will usually move around huge environments trying to find a mate. Somebody else says stay away from predators. That's another great answer. They're trying to move around. They might not have a set range, but predators do. So these animals might kind of move around to different areas. And then the last one, which I believe somebody said, was to be aware of their surroundings, which is a great response. And basically with that, or at least how I interpret that, is that animals are kind of looking around their area, just checking out what's new, which is something that we've all probably seen our cats or dogs do. Somebody says looking for a good cup of coffee. I've never seen a lion drink a cup of coffee, but that might be a reason a human moves around its environment. Yeah. So animals like lions, for instance, have lots of different reasons that they might move around. And scientists are still curious about that. Even if lions aren't making a huge trek across the entire planet, scientists will still use some of these same methods to track lions as they might use to track a sea turtle or a bird, because we want to learn more about why animals are moving. Somebody asked a question that said, what is the best way to track animals? Which is actually perfect because it transitions very well into our next data set. So another of the animals at Potter Park is this animal behind me, and I apologize, this is a white animal, so it's very hard to see on the sphere. But so this is looking at Taza, the snow leopard, the new snow leopard at Potter Park from a couple of years ago. And snow leopards are really interesting to track. And the reason for that is because they're super hard to find. Like you can see on the sphere, they are a white animal. Of course, they live in the snow, being a snow leopard. So it can be very hard to just see them physically. But snow leopards also live in an area of the world called the Himalayas. And snow leopards in the Himalayas are just very hard to find. The Himalayas are where Mount Everest is, so it's a very hard area to get to. But on top of that, snow leopards are also critically endangered. So it can just be hard to find them because there's so few numbers. So scientists incorporate all sorts of different ways to try and track snow leopards. I've got a couple of those options right here. So let's see if I can pull them up. So the first image that we can see right here, it might be a little bit difficult to see on your screens, but that option is a radio collar. So it's very similar to, we talked about the backpacks for the turtles or for the elephant seals. It's basically just a big black box that scientists are able to track. Of course, you can't glue something to the back of a snow leopard, so instead for big furry mammals, they usually use what's called a radio collar. Just goes around their neck. There's all sorts of different options for these, for different types of animals, for different sizes. But scientists are able to use this method to try and track snow leopards. Of course, one of the problems with this is that you have to find the snow leopard in the first place in order to put a radio collar on it, right? So if you're trying to find a snow leopard, this option might not be the best for you. It's great for tracking the leopards that we already know about, but not great for finding new ones. So another option that you might be able to use is something called a trail camera. This is an image taken from a trail camera of the snow leopard. It's a really, really beautiful picture. And it's interesting because using trail cameras, we're actually able to tell individual snow leopards apart. Snow leopards and a lot of other animals have individual unique patterns. So looking at a picture of the snow leopard, if you've seen the snow leopard on other trail cameras, you might be able to figure out which individual snow leopard is. And if you have trail cameras set all across the Himalayas, you could probably see where different snow leopards are moving. So of course, this is great if you happen to know where snow leopards are going to be walking around, but again, you might not know that. So scientists have other methods that we're still able to use. Another method that scientists can use, and again, I apologize, this is a white picture of snow on a very bright background, but this is showing snow leopard tracks. So you can see there's a yellow line kind of along the bottom of this image, and that's showing a measuring tape, just common measuring tape that you could get from anywhere. But scientists always like to include a measuring tape in photos like this so they can show that, yes, this is a snow leopard track. It's not a track of anything else because it's the right size for it. It's the right shape for it. So if you're out in the field of the Himalayas, you might be able to look for snow leopard tracks. Once you see the tracks, you would know that's a good place to put a trail camera. And the last option is honestly one of my favorites. This is going to be difficult to see, not because of the sphere, but just because it's very blend into its environment. And I'm curious if you guys want to leave in the chat, what do you think this is a picture of? You can see probably a lot of rocks, but there's something circled in a red dot right down here that's really important for finding animals. So we can see it's something that an animal leaves behind. Behind being the key word there. Let's see, waste, dung, poop. Yes, exactly, scat. So sometimes as a last resort, or even as a first resort, scientists will look for poop to try and figure out where animals are moving. Everybody poops. There's the great children's book about that. So scientists are able to look for scat in different environments and figure out what animals are living there. Scat is actually super interesting too, because as you might know, when we relieve ourselves, bits of our DNA actually are released with that. So scientists are able to take scat, run DNA analysis on it, and figure out which individual animal it came from sometimes. If not the individual animal, they can at least tell the species if it's hard to tell. So scientists can collect a bunch of poop from the Himalayas, run a bunch of DNA tests on it, and figure out which poop came from snow leopards. And then looking at that snow leopard poop, they're able to create a map that shows where snow leopards are moving around, what areas they live in, which is really important for protecting snow leopards. And we have one last animal right here. This is Phineas from Potter Park. I wasn't able to get a photo of baby Jolly up on the sphere yet, the new baby black rhino. But Phineas is a black rhino as well. And Phineas is really an important example of why scientists care about where animals live. Obviously, we're curious. Obviously, we want to learn new things. But one of the main reasons that scientists really want to track animals is being able to know where animals are that need to be protected. Black rhinos are really, really endangered. There's very few of them left in the wild. Most of them are in zoos. So Potter Park's actually really lucky to have a black rhino, which is pretty cool. But black rhinos are constantly hunted, right? For their horn, they're constantly poached. So if we're able to track black rhinos, we're able to know where all the black rhinos in the world are. That's a little sad because it means there's few enough black rhinos that we're able to know where everyone is. But it also helps us a lot because we're able to know individual information about each rhino and help that species continue to survive, eventually, hopefully to the point where we won't need to track them nearly as much anymore, and we can only track them out of interest as opposed to out of necessity. So those are all sorts of different animal tracks that we have on the sphere, all sorts of different reasons that we might track animals. I have a couple of other objects here that I wanted to show you that are specific to the MSU Museum. So for instance, right down here, we have what's called a museum special trap. So sometimes when you are tracking an animal, it might be an animal that's super, super tiny, right? So something like a mouse or a squirrel that there are so many of, it doesn't really make sense to attach a radio collar to them. It doesn't really make sense to do a lot of things like that because there are so many of them that, you know, they're just all over the place. But you still might be interested as a scientist in how many there are, or if there's a certain animal in a certain area. So this is an artifact from our museum education collections that shows how we have tracked mammals in the past at the museum, small mammals like mice. So this trap does not kill the animal. This is a live trap. So you can see there's a little flap right here. And so usually what will happen is that there will be some sort of bait inside this trap. Usually the bait will be specific to whatever animal scientists are trying to keep track of. And then scientists will put a bunch of these traps out all over an area where they think an animal might be. Then they'll go back and check the traps in a couple of hours. They'll keep track of how many animals they trapped that they were looking for. And then they'll release those animals and then reset the traps. And we'll do this over and over again. This could take place anywhere in the world. This could be, you know, thinking in the rainforest or the desert, or this could be on MSU's campus. This happens all over the place to try and figure out where animals are. There's a slightly interesting thing with this, though, that's different than when we're talking about radio collars or bird bands. And the problem with this is that some animals recognize a good thing when they see one. So there's something in animal tracking that's called a trap-happy animal. So it's an animal that realizes that, hey, this is just a box with food in it. When they're taken out of the box by scientists, they get measured, they get weighed, but nothing bad happens to them. So there's a possibility that when scientists are creating these studies, trying to trap a certain type of animal, they might be catching the same animal over and over and over again. So usually there's things built into their study that will stop that from happening. They might mark an animal that they know has been in more than once, or they might pay attention to special markings on the animal already, just to know that that animal has been in the trap several times and that they won't be keeping track of that, so it won't skew their data any. But that's just kind of a fun story that I like to tell. It's interesting to think about how smart animals are, even when we're trying to keep track of them. So that is the end of our Animals on the Move program today. However, it is only 10:26. So if you guys have any questions about the program, you can feel free to leave those in the chat. Or if you have any data sets that you'd like to see on the sphere, we have all sorts of cool things other than just animal movements. We can show things like space, weather, climate, all sorts of different stuff. So if anybody is interested in seeing those data sets, we're happy to show those as well. So with that, I can open it up. Does anybody have any questions? Oh, I see a question actually right there from Meredith that says, that is Jolly's dad. I guess that's more of a comment. But yes, that is Jolly's dad. Alina, did you see any other questions that I missed?
There was one question that asked, do they find friends while they migrate?
Oh, that is a great question. Yeah, so it's going to depend on the species. And of course, we don't ever want to assign human ideas to animals, right? So it's hard to say that an animal could have a friend because we don't know what that means for an animal. But some animals will definitely migrate together in groups. So if you think about animals like geese, for instance, flying in a V, you know that those animals will usually fly together to wherever they're going. And sometimes animals, even if they might disperse, will all come together in one area. So like talking about those monarchs, for instance, all the monarchs fly to a very specific forest in Mexico. So it's hard to say whether or not a monarch butterfly has a friend, but if it does, all those friends are together in the same place. So it's kind of interesting to think about that. They might be able to find friends, but.
And then we had a question in the Q&A, how do bears migrate?
How do bears migrate?
Yes.
That is a great question. People are very excited asking about bears on the sphere, and unfortunately we don't have any data sets for bears yet, but I'm going to look for some now because that's come up a couple of times. I actually don't know of any bears that migrate. So usually bears will hibernate is what we call it, right? So a bear will eat a bunch of food in the fall, get really, really fat, and then they will go into a hole or a cave and they'll sleep for the entire winter, most of the winter. They'll go in kind of like not quite a coma, but you know, they'll just go into a really relaxed state. Alina, do you know of any bears that migrate? I can't think of any off the top of my head.
I guess polar bears might count. So they move between like the ice floes and like the ground and everything. That's kind of seasonal migration. Yeah.
Yeah, no, that's a great answer. But we can look into that, and hopefully the next time we do this program, we'll be able to have that information. That's a great question.
And there's a question, how long have you been working for the museum?
Oh yeah, I have been working for the museum for the last 5 years, I believe, just in different capacities. But I've been doing this job for about a year.
Yeah. I've been here like 10 months. And then we'll just go in order. Can you put the climate on the sphere?
Sure. So there's lots of different data sets we have about climate. I didn't really go into the background of the sphere, but the sphere was developed by NOAA, which is the National Oceanic and Atmospheric Administration. So they have access to all sorts of cool data sets talking about climate, climate change, how things might change in the future. So I will look for one that is fun. Let's see. Okay, this is an interesting one. So this data, for instance, is looking at the concentration of carbon dioxide in the atmosphere. So carbon dioxide is something that we all know about when it comes to climate change, right? That's kind of the main gas. We talk about carbon dioxide going up into the atmosphere and creating a blanket that covers the entire Earth. And then when sunlight comes into the Earth, bounces out, but it hits the carbon dioxide in the atmosphere and gets kind of trapped there. So this data set is showing where all of the different concentrations of carbon dioxide are in the atmosphere. So you can see the redder an area is, the higher the concentration of carbon dioxide, and the bluer an area is, the less concentration of carbon dioxide. And there's literally hundreds of data sets all about stuff like this. If you guys are interested in seeing more, you can actually go to the Science on a Sphere website, which is sos.noaa.gov, and all of the data sets are available for you to see there if you're interested in checking out more or learning more about climate change or any of the data sets we have
Next question, is it what triggers animals to start to migrate? Temperature or sunlight?
Yeah, that's a great question too. So it really depends on the animal usually, and it depends on the reason that they're migrating. So when we're talking about things like birds or butterflies or sea turtles, it might be based off of temperature, but there's usually a lot of factors that would help an animal migrate. I'm not an expert in this area, so I'm sure that individual scientists who are studying these things do know a lot of the individual triggers for it. I could make some guesses. It probably is things like temperature. It might be things like sunlight. So if they know that the sun is rising later in the day and setting earlier in the day, they would know that that means that it's time to start migrating. There could be all sorts of different things, or it might even be based off of other species. They notice that there's, species have been moving out of their area, or, their food source is moving out of an area, so they just kind of follow that food source. Another option that we didn't talk about would be things like the migrations that happen in Africa. So that might be based off of things like rain cycles, for instance, where animals are just basically moving to where the food is, where the grass is nice and wet from the rain, so they're able to, have a source of food. So there could be all sorts of different reasons. Great question.
We have 2 more questions and then a request. So how long does it take to track?
Yes. So that's going to depend on what animal it is, but it's a really interesting question. So when we're tracking an animal, you want to get kind of a complete picture of where that animal's moving, right? So I'm going to pull up the data set that we were looking at before with the leopard, or not with leopard seals, the elephant seals, excuse me. So this data is taken over a long period of time. I'm gonna look up and see, because I don't quite remember how long it was collected for, but it was collected over several years. So it was from January 28th, 2005 to February 1st, 2006. So that was tracking elephant seals for an entire year to try and figure out where they are. Some animals might be tracked for even longer if they're, slowly moving throughout different spaces. Or they might only track them for a couple of months if you're just trying to see, the specific path that monarchs are taking from Michigan to Mexico. You don't care about the path they're taking back. You might only track them for the time it takes them to do that journey. So it's really going to depend on the individual species. And then, of course, once you have all this information, you have to figure out what it means. That's going to take a long time, too.
So do migration patterns change over time, and do we have a data set that shows it?
Yes, migration patterns definitely change over time. So there are actually some scientists at MSU that aren't studying quite this, but they're studying what we call the ranges of animals. So just where you can find different animals in certain areas. And of course, the reason that those things are changing is because the climate is changing. So we're talking about how birds and sea turtles change or move around based off of changing temperatures. Climate change means that temperatures are constantly changing. It might be getting warmer, it might be getting colder, it might just be more intense, but regardless, we know that temperatures around the Earth are changing and affecting things, including animal migration. So if, for instance, Michigan is staying warmer later and later in the year, birds might notice this and start staying in Michigan later in the year. There might be issues with things like flooding, or maybe an area starts getting really intense weather based off of climate change. That migration path might change based off of those things. It's going to be a gradual change over time, and they're constantly changing over time anyway, over thousands and thousands of years. But yeah, migration patterns definitely can change. They aren't just stuck to one route.
All right, and then we just have one request. Can you do space?
Yes.
Totally do space.
Does the person, I don't know who left that question, but what about space do you want to see? I can give you a couple options. We can look at planets, we can look at a star, or we can look at the entire observable universe. And anybody who wants to chime in on that, we can do those 3 things, or I can show you a couple of them. But okay,
Planets.
Perfect.
And entire universe. We have 2 requests.
Cool. I will show you a planet first. This is one of my favorite, well, I'll show you my favorite planet first, but it's kind of cheating. Let's see. Okay. So This is my favorite planet. It's called Earth. We live here. This is, like I said, kind of a cop-out, but it is really cool to show the planet from space. This is a really cool data set called Blue Marble. It's named after the famous image taken by NASA of the Earth in the 1970s. But it was collected from a bunch of different pictures, and it took a couple of months to compile all these pictures together to make this, this data set. So that one's really cool. But an actual planet that is not the one we live on is Mars. And so this is another one of my favorite planets that's really fun to pull up on the sphere. There's all sorts of cool data sets from NASA that are available on the sphere, so we can learn all sorts of different things about Mars. But I really, really love just looking at this one. It's a really high quality picture, so you can see all the different craters and crevices and mountains and all the cool stuff that's happening on Mars. So this is a really fun data set.
We do have a request for Pluto as well, which is a less high quality planet data set.
So one of the cool things about Pluto is that it's so far away, we have not been able to take a very good picture of it. So for a long time, the best photo that people had of Pluto was basically just a fuzzy dot. But I forget which mission it was, but there was a mission that very recently went past Pluto within the last couple of years and was able to take a really high quality image of Pluto. And it's very sweet and nice because you'll see it's rotating around us right now. There's a big patch of ice on Pluto that's shaped like a heart. And so that's just really nice and sweet. I always like showing that around Valentine's Day, that Pluto has a big heart, even though it's a small planet. Yeah, and then I will show, just as the last one, the Observable Universe, which is one of my favorite data sets. Let's see. If I can find it, hold on.
Apparently the mission to Pluto was New Horizons.
Oh, New Horizons, thank you.
Somebody has told us. Thank you.
Okay, so unfortunately, I'm not able to actually find the image of the Observable Universe, so I'll show you something else instead. This is our evidence of the universe. So this is cosmic background radiation. So this is radiation that is spread across the entire universe as a result of the Big Bang. We're still able to measure it today, even though the Big Bang was so long ago. And this is basically how we know a lot of the things we know about the universe, how it's expanding, being able to measure distances, all sorts of different stuff is based off of this cosmic background, this cosmic microwave background radiation. So this is something really cool. I'm sorry that I wasn't able to pull up the Observable Universe. Apparently it is no longer available on the sphere, but you can see it on the SOS website if you want to check it out. It's just called the Observable Universe. Yeah, awesome. Well, this has been a great program. You guys have been a great audience, and we really appreciate you tuning in. If you want to check out other programs, we are doing another program called Mystery of the Penguin Feather that Alina is going to be running. That is in December, so it's a great kind of fun winter program. You can find out more information about that on our Facebook or on our website. And again, thank you so much for tuning in. I hope you all have a great day.